If your livelihood depends on the outcome of your crop, consider spending extra time protecting your crop from pests. Take pecan or fruit trees, for example. By applying the correct pesticide at the right time and the right amount to the right area, you can maximize your yield and limit production costs. Probably the most important factor in making sure all these variables come together is the application equipment. Application equipment has to be the proper type, the proper size. It has to function correctly. It must be calibrated, and the person operating the equipment must be trained to carry out this all-important job. This is a typical air blast sprayer. The tank should be corrosion resistant and designed for easy filling, cleaning, and draining. Agitation in the tank should be sufficient to keep all pesticides thoroughly mixed, both when spraying and when the spray nozzles are shut off. There are two types of agitation systems: paddle or propeller type mechanical systems and the hydraulic jet system. Both should keep the pesticide solution thoroughly mixed. Pumps used in air blast sprayers are usually piston or centrifugal pumps. As a general rule, piston pumps are used for high pressure application, up to 600 pounds per square inch. Centrifugal pumps are used for applications requiring a high volume of liquid at low to medium pressures, 50 to 200 pounds per square inch. On an air blast sprayer, the pressure regulator isn't commonly used for changing the system's pressure, even though it can do this. The pressure regulator, which can be opened and closed, may be spring-loaded, or it may simply be a valve that directs varying amounts of pump output back to the tank. Spray pressure in an air blast sprayer is set by regulating the pump speeds on models with a centrifugal pump. This can be done by varying the engine RPM on engine-driven models. Operators must maintain engine speed at the RPM required to produce the desired pressure. If the engine speed changes, it will change the pressure and the spray volume output. Pressure gauges monitor the system's pressure. They should indicate the pressure at the sprayer manifold. The spray system is usually set to operate at a certain pressure to assure a particular output of the system, and the pressure gauge indicates any change in that preset pressure. A change in the preset pressure alerts the operator that the system is malfunctioning. Malfunctions may be caused by clogged filter screens, changes in pump output, or regulator problems. Manifolds deliver the pesticide solution to the nozzles that are mounted on them in a manner that will deliver a certain spray pattern. On air delivery sprayers, nozzles meter the spray material into the air stream. By atomizing the liquid, the nozzle influences the droplet size and the number of droplets obtained from a given volume of liquid. The type and location of the nozzles also influences the spray pattern. The spray nozzle is made up of the body, cap, strainer, disc, core, or tip. Even though the disc and core are made of materials such as hardened stainless steel, tungsten carbide, or ceramic materials, they will wear and therefore should be checked periodically and the sprayer recalibrated to adjust for this inevitable wear. There would be no air blast without a fan to create the air stream, so the fan, either axial or centrifugal, is very important. Together, the air stream and the nozzles atomize the liquid from the tank, breaking it up into small droplets. Most sprayers depend on the nozzle for atomization of the spray. The effect of the air stream on spray droplet size is proportional to the velocity difference between the liquid spray and the air stream. The greater the velocity difference, the greater the atomization. The spray droplet breakup will be minimal if the nozzle injects the spray into the airstream moving in the same direction as the air. Likewise, if the spray is injected into the airstream directly against the airflow, the atomization will be maximum. The major function of the airstream is to deliver the pesticide into the canopy of the tree or crop and to uniformly deposit it on the fruit foliage and other parts of the plant. Characteristics influencing airstream coverage include air volume and velocity. These are expressed in cubic feet per minute, or CFM for volume, in feet per minute, or FPM for velocity. Both volume and velocity are affected by fan type, size, speed, and volute design. All these factors work interactively to affect the performance of the air blast sprayer. The goal of any air blast pesticide application is even distribution of material. This is accomplished when the spray-laden air overcomes and replaces the resident air in the tree. If the sprayer is moved past the tree too fast, if the tree is too dense, or the sprayer output is insufficient, the resident air will not be displaced, and the result will be poor coverage. There are some factors affecting coverage that we cannot control, such as humidity and wind. Extremely low humidity causes spray droplets to evaporate. This prevents them from ever reaching parts of the tree. Spraying when the humidity is above 50% will help. Winds that blow across spray patterns will prevent good coverage also. That's why spraying during calm periods is best. Other factors can be controlled by the operator. Indeed, they must be if complete coverage is to be accomplished. These factors are ground speed, pressure, timing, nozzle and nozzle placement, air speed and direction, and spray volume. Sprayer speed usually ranges from 2 to 5 miles per hour, with better coverage obtained at the lower speeds. 3 to 4 miles per hour is most common. Usually, manufacturers recommend spray system pressures in the range of 60 to 260 pounds per square inch. Manufacturers also provide nozzle arrangement setups. The number of nozzles should be arranged on the sprayer manifold so that 2/3 to 3/4 of the sprayer output is directed to the top half of the tree and 1/3 to 1/4 to the lower half. The proper positioning of the air guide or director will aid in the proper placement of the spray on the target. Nozzle size, pressure, and speed all determine spray volume. Therefore, first select the desired spray volume and speed, and then determine nozzle size and pressure. Spray volume can vary from 15 to 250 gallons per acre, with the most common range from 50 to 150 gallons per acre. Make decisions based on sound information from pesticide labels, operators' manuals, extension pest control experts, orchard measurements, and experience. Keep in mind the knowns and unknowns. Here are the known factors: the gallons per acre desired, the miles per hour desired, the number of nozzles on the sprayer, and tree row spacing. Information that needs to be determined and set for the machine can be termed unknowns. They are the gallons per minute of output needed and the size and placement of nozzles. Output in gallons per minute for a sprayer traveling down each side of the row from one side can be calculated with the following equation. Gallons per minute equals the gallons per acre times miles per hour times tree row spacing expressed in feet divided by 1,000. Here's an example. Let's say your gallons per acre is 120. You're traveling 3 miles per hour using 8 nozzles, and your tree rows are spaced 60 feet apart. How many gallons per minute do you need? Multiply 120 by 3 by 60 and divide that number by 1,000. That's a constant. Your answer is 21.6. That means you need 21.6 gallons per minute. How about the size and placement of your nozzles? Well, there are 8 nozzles. Select 8 nozzles that meet the